Yes.
Okay. So we will try to, we already talked about the effect of concentration. So what was the two main points which we need to know? Anyone? For concentration, if you increase concentration, it favors. If you increase concentration, it favors which direction? Concentration of reactants, I have to specify. Then it will favor forward.
X.
No, concentration. It will forward or on the right side. The equilibrium shifts to the right. And if you decrease the concentration of reactants, then it favors backward, or you can say left. Preferred is this one, right or left. Any questions regarding this?
No.
Any questions regarding this?
No.
No. Okay. So this we have already done as a first factor. The second factor we talked about was temperature. How does the temperature affect the equilibrium? So for temperature, we said if you increase the temperature, the reaction favors which direction?
Left.
No, wrong.
Endothermic.
Very good. It has to be endothermic, and then you have to check which direction is the endothermic. And if you decrease the temperature, then the reaction favors exothermic direction. For example, again, I will give an example. For example, if you had NH3, N2 plus 3H2, giving you NH3. In this case, this is the forward is exo, the backward is endo. So in this case, if you increase the temperature, which direction will be preferred? If you increase the temperature, which direction would be preferred? Yes, please.
Endothermic.
It will be endothermic. So when you increase temperature for this, it will be endo always, but in this reaction, it will be backward. For this reaction, it will be backward or to the left. But if I give you this reaction, this is endo and this is exo. I'm still increasing the temperature. For this reaction also, I'm still increasing the reaction. So here also, it will favor the endothermic. But now what will happen? It will favor the forward, which is right. The reason is in this case, in the second reaction, what is happening is you have a endothermic in the forward direction, while in the first example, the endothermic is at the backward direction. Is this thing clear to us?
Yes.
No, good. So the next thing is, we move on to the next factor, that is pressure now. Now for pressure, you need to understand again how to know which direction will be preferred. That will be based, the reasoning is different. Like for concentration, you decide in a different way. Temperature, you decide in a different way. Same thing is the pressure. Now whenever you increase pressure, the reaction prefers less number of moles direction, while if you decrease the pressure, then the reaction prefers more number of moles direction. Is this in clear?
Yes.
Still, how many are absent now? Maryam, Hala, Safa, Tasneem.
Hadra, Rahma, Maham, Zainab.
Rahma is not coming to, even she did not do the quiz. Okay, I have to, we will see. At the end of the lesson, we will see what to do. So now let's talk about, and now remember one very, very important thing about this, which is a major confusion, that this pressure is only for gases. This is only for gases. So you apply this less number of moles direction or more number of moles direction only for gases. Like for example, let's first of all understand the meaning of less number of moles and more number of moles. Same reaction. How many, all are gases right now? So how many moles on the left side? Total moles?
4.
4, very good. 1 plus 3, that is 4 moles. While on the right side, it is only 2 moles. So if you increase the pressure in this case, the first thing you have to say, because that is known in your exam, they will ask you for the reason or the justification. So reason is that when you increase the pressure, it will favor less number of moles direction. So in this case, the less number of moles direction is forward or right. So you would say favored. So you would say the equilibrium shifts to the, equilibrium position shifts to right.
This is only for this particular example, right?
Yes, but this is always true.
Okay.
That is, when you increase the pressure, it has to go to the less number of moles. In this example, the less number of moles is in the forward direction. I will take another example to show. So if the equilibrium shifts to the right, then what would happen is there will be more of ammonia produced. Did everyone understand this?
Yes.
Okay. And suppose I change this to, I want to change the color. Okay, now suppose I decrease the concentration, what would happen? Now, if I decrease the concentration, what would happen? Yes, please. If in the same reaction for ammonia, if I decrease the concentration, what is going to happen? Anyone? No question. No one.
It will move to the left.
Okay, so it will first, again, your explanation is wrong. The first thing you will say, it favors more number of moles. Based on that, you know it will be to the left. Is this thing clear? And therefore, less of ammonia is formed.
Wait, so increasing concentration favors the side with more moles?
Did I say that? It's not concentration, it is pressure.
Okay.
Concentration is always in the forward. Concentration,
Okay.
if you increase the concentration of the reactants, it will always favor the forward, irrespective of any reaction you are given. The problem is with the temperature and the pressure. You have to look at, if you are looking for if temperature change, then you have to look for which direction is exothermic and endothermic. That will decide the forward or the backward. Same way, if you are looking for the effect of pressure, then you will have to look at which direction is less moles or more moles, and then decide. Any clarification? Hala, you are there?
Yes, sir.
Okay. Like for example, now I'm taking another example. Let's say I give you this reaction, PCl5 changing to PCl3 plus Cl2. This is a gas, this is a gas, this is a gas. Now, if I increase the pressure over here, what would happen? Now, we know increased pressure means less number of moles. That's the first thing we should know. Now, check. This is 2 moles. Sorry, this is 1 mole and this is 2 moles. Any problem?
No.
So, which direction is less moles? The backward.
Backward.
So, therefore, backward. Better word, again I'm repeating, backward, or you say to the left. So your answer would be equilibrium position shifts to the equilibrium position, or equilibrium shifts to the left. Is this thing clear?
Yes.
And if I decrease the pressure in this case, what would happen? I know when you decrease the pressure, it has to go to more moles. That's a
So
simple.
shift to the right.
Very good. So backward, instead of backward, it would be forward, and then the equilibrium will shift to the right. So the important statement which you need to know is this thing. This is the important thing. This part is the important thing. Is this thing clear to us?
Yes.
Any clarification required for this?
No.
No. So every factor is explained in a different way. Your view, the way to explain or reasoning is different. Now let's say I have calcium carbonate solid. I'm just making up one reaction, forms calcium oxide solid plus carbon dioxide gas. Now I increase the pressure over here. What would happen here? Just a minute. Yes, Maham, what would happen? Maham, you are there?
Yes.
Yes, so what will happen to this if you increase the pressure?
The equilibrium would shift to the left, to the right.
First, again, see, the problem is the way you are moving.
It's solid.
First thing you
Oh,
have,
they're solid.
the first thing you have to say, increased pressure means less moles. Are you getting? That will give you 1 mark.
Yes.
That will give you 1 mark. Less moles direction. Simple. Directly, the moment you write this thing, you get the first mark. This is actually the reason. Then look at your reaction. Yes, someone said solid, Safa. So
Yeah,
this is 0 moles. This is 0 moles. This is 1 mole. So that means less moles direction is on the left side. So
wait, teacher, why is CaO 0 and CO2 1?
because these are
right. Okay.
These are solid. You said that. And less number of moles direction means it will favor the left. So equilibrium shifts to the left or backward. Maham, clear?
Yes.
So remember, your first statement has to be this thing, less or more moles.
Okay.
Because that quickly gives you 1 mark. Straight, you get 1 mark because of that. That is the reason. Okay, now let me consider another one. And H2 plus I2 gas gives you HI. Now, Let me see who. Okay, Tasneem Khalid. If I increase the pressure, what happens?
I can't hear. Increase or decrease the pressure?
Increase.
Increase, it will shift to the side with the less gas moles.
Very
So
good.
it would,
Less moles direction. So
they're equal.
they are equal. Very good. So what happens over here?
It doesn't change.
Very good. So remember this gives us another important concept, that if equal moles, which moles? Remember, gaseous, on both sides, then there is no effect of pressure. Is this thing clear to us? So here you had 1 plus 1, that is 2. Here also you have 2. So in this case, whether you increase the pressure or decrease the pressure, there is no effect, because there are equal moles. So when they give you the reaction, you have to take care about the state also, whether they are gases, liquids, or solids, or you have to also take care whether the moles are same or not before you decide. Okay, Hala, you have, I'm giving you another reaction. You increase the pressure, what happens here?
None of them is gas.
Sorry?
None of them is gas.
So?
Doesn't shift.
Very good. So in this case also, no effect of pressure.
But teacher, should we still write the increased pressure favors less
Nothing.
moles direction?
You cannot say it in favors less moles or nothing. You just say no, no effect of pressure, as no gaseous substance involved. Because the first condition for applying the pressure, the concept of pressure is that they need to be gas. Do you get the point?
Yes, so at least one thing needs to be a gas.
At least, yes. Here there is no gaseous substance, because it is only the gaseous moles that you have to consider for pressure. Any clarification for anyone? Okay. No. Okay. Thank you. 2 of the participants, they have left.
Teacher, I have a question.
Yes.
You know the example you gave of PCl5?
Yes.
You said that the equilibrium position shifts to the left when you increase pressure.
Okay. Yeah. Here.
So does that mean that less product is produced?
Yes.
So less PCl3 plus Cl2 is produced.
Very good.
Okay.
Whenever finally you will know whether the reaction favors the right direction or the left direction. So if it favors the right direction, it means more of product. If it favors left direction, that means less of products.
Okay.
So that would always be the end of your explanation. Means when they're asking you, because yesterday as we talked about, that this is our aim, the product. So your answer has, if they're asking for an explanation, what is the effect of something, then your answer has to end in more moles or less moles of the product. Okay. Now moving on to the next factor, that is catalyst. Now what are catalysts? Everyone knows that. I hope so.
A catalyst increase the rate of reaction by lowering the activation energy.
That second statement is wrong. Substance which
By choosing an alternate path that has lower activation.
Very good. Which increases the rate of reaction without undergoing any change themselves. This is the definition for catalyst. Any change themselves. So this is the definition. So there are 2 points over here which the examiner is looking at. One point is it increases the rate, and the other point is without undergoing any change. Because if a substance increases the rate but it is changing, then it is not a catalyst. Is this thing clear? So what you all were saying, alternative path of lower activation energy or lowering the activation energy, that is wrong. That is not the definition. The definition is this. Is this thing clear? How it does? How it does? That is by providing. So if they need an explanation, then you will add this by providing an alternative path of lower activation energy. So it does not lower the activation energy, it goes through another path of lower activation energy. Lower activation energy. What's the difference between this alternative path of lower activation energy and lowering the activation energy?
The catalyst isn't lowering the activation energy, it's just taking a different route that has lower activation energy.
Yes, very good. It's like you want to buy a phone which is 1,000 dirhams. Now you don't have that much amount. So you don't go and fight with the shopkeeper and give him less money. That is lowering the price. You fight with him, no, I will not give you, I will give you only 500 dirhams. So that is lowering activation energy. But what you will do is, instead of the iPhone, let us say, you will go for, let's say, Nokia with the same features, most of them the same features, you can buy it for 200 dirhams. So this is, you are going for an alternative. Is this thing clear? You end up doing the same, having the same functions approximately, specifications, but you are going for an alternative phone. Is this thing clear to us? The meaning of alternative path of lower activation energy and lowering activation energy? So remember, that is wrong when you say lowers activation energy. Like if I try to show it graphically, we have done it several times before also. Like if this is an exothermic reaction, this is your enthalpy. This could be explained in terms of endothermic also. This is your activation energy. This is your activation energy. This is your reactant. This is your product. Now what the catalyst will do is, it will not bring this thing down. Instead, starting point would be the same. It will take another route. It will take another route. So it goes over here. Now this is the activation energy with catalyst. And this is without a catalyst. Any questions for this?
No.
So we understand the meaning of alternative. So you can see it is going through another path. It is not bring, like when you go to the school, that one route is more traffic, so you take another route. You don't bring the school closer to your home. You take another route where there is less traffic. Same thing is over here. Clear to all of us?
Yes.
Yes.
Okay, now the question is, what is the effect? The question is, what is the effect of the catalyst? The first thing is, yes, anything you know about?
It doesn't have an effect.
Then why were you studying about it?
It just increases the rate of reaction.
It increases the rate of both reactions, so it doesn't affect the equilibrium.
Okay, then yes, what you are saying is correct. First thing is, it increases the rate of forward and backward to the same extent. To the same extent means, if the rate of the forward is doubled, the rate of the backward will also be doubled. Clear? Because of this, what happens is the equilibrium position is not changed. Equilibrium position is not changed, does not change. But what is going to happen is, what else will not change?
The amount of product and reactant.
Very good. No, you don't, again, you don't need to say reactant. Butina, you don't need to talk about the reactant. Our concern is the product. Clear? So the amount or the yield of product does not change. That means no effect on it. But what is happening? The equilibrium position is achieved quickly, less time. Equilibrium position is achieved quickly. That means less time. Like for example, when you go walking to the school, you take 1 hour. So instead of that, what you are doing is you are going by car. It takes 15 minutes. So did the school come closer to you? No. Your rate of your speed has increased. So that's why you are reaching the school quickly. Is this thing clear to us?
Yes.
So the main effect is that the equilibrium is achieved quickly in less time, but rest of the thing is not changing. And why this is happening? This is happening because it increases both the rate of forward and backward to the same extent. So they meet quickly. And let's try to draw the graph to show this. Graphically, we try to explain this. Now, if this is your rate and this is your time or progress of reaction, we talked about this in this is the rate of forward reaction, this is the rate of backward reaction. It is this time that hello, how do I know that equilibrium is, after this the equilibrium has been achieved?
When both are the same?
What do you mean by both?
The forward and the backward reaction.
Very good. The rate of forward and the rate of backward are same. So we know that the equilibrium has been established. Now what happens is when you use a catalyst, the forward reaction speed is increased, the backward reaction rate is increased, but the position of the equilibrium is not going to change. They will meet at, but you obtain it quickly. You obtain this quickly. So the rate of forward is increased, the rate of backward is increased. Therefore, they meet before time. Is this thing clear? So this is how you will show the effect of catalyst. Is this thing clear to us?
Yes.
Mariam is there?
Yes.
Yes. Which Mariam? There's
Raza.
and the other one, Mariam is not saying anything.
Teacher, I have a question.
Yes.
The one in blue, that's with the equilibrium with the catalyst, right?
Yes, with catalyst. I will write down. That's my mistake. That is with catalyst. Is this thing clear to all of us? Now, how they can ask us a question over here is, how they can ask a question over there. This is a problem with the Zoom. There is only 40 minutes. You cannot take more than that time. But as far as I know, we have got a mail. I think you must have also received a message from on iCampus that by this Thursday, you will be provided with an email from the school on Teams. Already the groups have been made on the basis of the class. So that would be easier to join over there. That's why I did not start the lesson on Teams. Okay. Okay. Now I have this reaction. Now remember, we started this discussion by saying that some of the reactions are processes are industrial manufacturing process. So we need to manipulate the reaction. Now this you have done this in your IGs. This is known as a Haber's process. for manufacture of ammonia. Now, a quick review of the reaction conditions. That is very important, that why did we choose this reaction. Now, over here, your reaction conditions are, temperatures are 400 to 500 degrees Celsius. This is your exothermic, this is your endothermic. We will come to this. And the pressure is around 200 atmospheres. And you use a catalyst, which is usually iron or nickel. Now, what they will ask you is that you are saying that the temperature used, this is the reaction conditions. Now, the questions would be, why temperatures below 400 or above 500 not used? Or in another word, they may say, why 400 to 500 degrees Celsius used? Why not less? Why not more? Any idea? Based on what we have just talked about. Who will explain? Yes, please.
Is it the energy? Is it because they need to reach a specific energy?
You are explaining what, more energy or less energy?
No, I'm explaining the temperature. Like if the temperature, they need the temperature to be specific so that it can reach a specific energy.
Why only 400 to 500? Why not more than 500? Why not less than 500? 400?
Because isn't it like the perfect temperature for all the cells to produce more product?
No, every reaction will be different. Every reaction, the reaction conditions are different. Like if you are doing a cracking, then it is a different temperature. The reason is, we go back to this thing. Why not higher than this? Not higher than 500. The reason is, at higher temperature.
Because it's an optimum temperature for the catalyst?
No. Why it is optimum? The reason is, at higher temperatures, what would happen? Endothermic would be preferred. Endothermic preferred. And endothermic is backward for ammonia. That means you will get less of ammonia. As you can see over here, the backward direction is endothermic. So if you increase the temperature, the reaction will prefer the backward direction. Is this in clear? Is this in clear?
Teacher, can you scroll down?
Yeah. So what is happening is, if you increase the temperature, the reaction will favor the endothermic, and endothermic means the backward. That means less of ammonia will be formed. And the industrialists, they want more of ammonia. Is this in clear?
Yes.
So this means we should use a lower temperature. So why not lower than this?
Because then atoms won't have the enough energy to...
Yes, very good. So lower than this would not activate the reaction. Activate the reaction means that a minimum activation energy is required. Minimum activation energy is required. So you have to provide, like for example, petrol or diesel, they will burn, but you have to show them a matchstick. You have to start the fire. Did you get the point? So this 400 is the minimum temperature required to start the process. If you take lower than this, then the reaction will not start. So lower than this temperature, what will happen? Reaction will not start. Is this thing clear to us?
Yes.
Same way, why you are using a high pressure over here? Because it's just 1 minute more, so I'm explaining it quickly. Why high pressure you are taking? Because high pressure means less moles. This is the less moles direction, so you will get more of the product. Understood?
Here, can you repeat that?
Okay, I'm saying we are using a high pressure over here, 200, because the normal pressure is 1 atm. So if you are using a higher pressure, then the reaction will favor less number of moles. So this is the less number of moles direction, which means you will get more of ammonia. That is what we wanted. Is this thing clear?
Yes.
And why are we using the catalyst? So this is what they can ask you. Last minute, why catalyst? Because lower temperatures are used. Lower temperatures are used, so the rate of reaction is slow. Reaction is slow. So therefore, catalyst increases the rate. Increases the rate. Because you are performing the reaction at a low temperatures, at a, that is 400 to 500 is a low temperature industrially. So what we are doing is, we are using a catalyst to speed the process. Is this thing clear?
Yes.